All right, ladies and gentlemen, welcome back. Couple of things in terms of announcements, and then we're going to get back into doing organic nomenclature. The exam, I believe I have released the answers, and I have to still upload the question or the answers, the handwritten answers. So those will be uploaded to Blackboard later today. If you have any questions about your marking, please go through and make sure that it is correct. There appeared to be some glitches with both Blackboard and the upload procedure, so just make sure that everything is there in terms of the answers that you submitted. With regards to your upcoming presentations, everything's being finalized right now. The only thing I am asking is for one or two people who are in section L4, if you could switch to any other section. There's space in any other section. Right now I'd like to get the number down to 9 or 10 presentations that day rather than the 12 that it is currently at. So if anyone is in L4 and can switch to any other section, just send me an email and we'll do that. If you could do that by the end of today, that would be great. Then I will send out the finalized schedule tonight or tomorrow, and the like. The other thing I was going to talk about is your presentations. There was a lot of discussion as to how this is going to occur, and I will create a short video on how to use Blackboard and how to set up to present your work, so sharing your screen and presenting. I'm guessing most of you are going to be using PowerPoint, so that's what I'm going to focus on. If you are using something else, you just have to share a different screen and use it appropriately. So I will show you how to share PowerPoint, how to advance your slides, and the like. And I will be there for all of your presentations anyway, so yeah, so I'll be able to assist students there. That's it in terms of presentations. And yes, your presentations are live. And to answer the question about the average on the term exam, it was like 62%. So go from there, which is exactly where I kind of wanted it to be. So I'm not concerned. I think it was good. So what I am more concerned about in terms of the exam is the observation that some students thought they uploaded their file and didn't, or thought they answered their questions and do it. Nope. Benjamin, you must do your presentation live. It's kind of like a job interview or a presentation to clients. The classroom environment, this is what we're doing here. Although it may be absolutely scary to you right now, it is actually the safest place to practice giving presentations. So doing it live here is critical to giving you the skills to do it at a job interview, to do it for a board meeting or something to that effect where you have to present. And the more times you practice in a reasonable environment, the better you become at it. So, all right, so off to the course material. And I just need to back this up a little bit. Give me a sec. All right. There we are. Taylor's question, do you need to have your camera on for the presentation? It depends on how you present, but most likely you're going to be sharing your screen. So we don't actually need to see what you look like. If you want to have it on, it would sit in the bottom corner. So just for reference, let me just share this. Because I do things slightly differently, on the screen in front of you right now is me in the bottom corner over there. But because I'm sharing the exact same camera, yours would be a picture of you down there, and the main screen would be your PowerPoint. I'm just doing it differently because I want to superimpose myself on the PowerPoint presentation. So anyway, this is where we get that, Andrew. I did post it. I forgot to link it to the course to the course group. So I will do that this afternoon. So yes, it will all be uploaded. I'm not going to have time today's class to do all of these examples. There's 3 pages of examples afterwards. I will do some of them and upload that file as well, just so you get a global understanding of how these things are set up and done. But we're going to go through as many as we can today. So I wanted to do just one more of these, and then we will move into nomenclature. So the last one that I wanted to do is I wanted to draw the condensed structure of that group right there. And in drawing the condensed structure, you need to realize that at every apex, there's a carbon atom, like that. So there's a carbon atom right there, and every carbon atom, I'm just going to have to erase those just to simplify this. Of course. There is enough bonds to form 4 bonds for every carbon atom. So I'm drawing in blue all of the bonds that are not shown, and if they're not shown, they're bonds to hydrogen. So to write out this structure, you would have a CH3 group, a CH2 group, that represents that, and then we have a CH bonded to another CH3 group. And then it goes CH2, CH2, C, double bond O, H. That is a perfectly great representation of this. We can simplify it a little bit. So I'm just going to rewrite CH3, CH2, CH, CH3. That's not changing. I can't do anything with that. But what I can do, if I have the same group multiple times, I can just present it like this. That doesn't mean that they're all attached to the CH group. That's not possible to all attach them there. And through the context and experience, you figure out that that is part of the backbone chain. That is that CH2 group. Just comes through experience. And then finally, this functional group that is presented here, just give me a second, Afrin, is often just labeled CHO. Go ahead, Afrin.
I was wondering, how do you know that? So I guess if you look at what you wrote out for that 4th carbon, not in your line thing, but like that you wrote out, how do you know it has 3 hydrogens attached to it?
1, 2, 3. You're talking about the one that I'm circling in red right now?
No.
Okay, which one?
Attached to the 3rd carbon.
Oh, the 3rd carbon. I thought you said 1st carbon. Right there. How do I, this one right here that I just circled is the one you're talking about?
Yeah, but like in what you wrote out, you have like CH bracket, CH3 close bracket. How do you know that there's 3?
Oh, okay. Oh, I understand what you're saying now. Thank you. All right, I can do that. That's what I want to do. That's what I want to do. So in terms of, let me just zoom in on that. I like this. Having fun with tablet. This is a methyl group, all right? And so what one needs to do here is realize that it is also going to form 3 bonds to hydrogen in order to give it a total of 4 bonds total. Okay?
So in cases like that, is it always going to be a methyl group?
No, you could have, you're going to see examples where there's ethyl, methyl, different things coming off, and we will just name them appropriately. Okay?
Okay.
Yeah. So I just happen to use ethyl because it's a simple, easy substituent to draw. And here, realize that our representation was meant to be drawing these things, and it just gets unwieldy to draw, a cyclopropyl group or something like that. All right, so that's that representation of all of this. And either one of these two is acceptable. Where I want to take this now is to look at nomenclature, and I'm going to admit this up front. Lots of rules, a reasonable amount of memorization. There's no other way to get around it but to actually use it. And the best way to actually learn this is to practice it. So let's go through the rules and the terms, and then we'll start applying it as best we can for the remainder of the class. So this is the hydrocarbon nomenclature. And of course, organic chemistry is literally, organic chemistry is the chemistry associated with carbon atoms, and you have to name that carbon backbone or that carbon chain. The name that's presented here is the hydrocarbon chain as the main chain. If it is attached to the side, as we just saw, we had a methyl group attached, this would be called the radical name. And I mentioned, I kept using the term methyl, ethyl, propyl type of idea. But you are expected to know carbon atoms: methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane. 1 to 10 carbon atoms. If it's the radical, the end product is replaced with YL, methyl, ethyl, propyl, butyl, etc. We can go beyond 10. And 10 was decane, and then it starts adding un for 1, do for 2, tri, etc. Undecane is 11, dodecane is 12, etc., etc. We're probably not going to be getting more above 12 or 13 carbon atoms in a chain during this assignment, but realize that it does go on, and even I have to look up icosane and triacontane. I don't remember them. I look them up if I need to use them. So, but I do know that it would be un icosane for 21, do icosane for 22. So this idea here, un, do, tri, blah, 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 is something that you need to know and be able to apply. That's the hydrocarbon. The functional groups, and I'm going to point out that this table is presented differently than the table you have. For whatever reason, the table you have is almost randomly organized. I don't know why. This table lists the functional groups in order of precedence, and we'll talk about precedence in just a little bit. So these are the functional groups, and you are sadly expected to know these as well. That being said, you've probably seen many of these or some of these functional groups before. Here we have a functional group where there's only one little tilde. That's this little thing right here. That infers that it's bonded to something, okay? And that something is given the symbol R. An R group, it could be an R or an R primed group, whichever is, thing. The difference between R and R primed, really there is no difference. It's just to say that they could be different. And in the example we have here, in one side it's a methyl group, and the other side it's an ethyl group, or a propyl group, that's attached happens to be this ester. So they can just be different. But R just represents any organic compound. If there's only one tilde, this thing has to exist at the end of a hydrocarbon chain. So where there's two, it can exist somewhere in the middle of that chain. So carboxylic acids have the highest precedence with 1, then esters, acid chlorides is presented there. The amide group, you may not know the name, but this C double bond O, N onto something, is common in biochemistry. It is part of the amino acid molecules, and it forms the backbone of proteins that engages in hydrogen bonding with other proteins, with other proteins in, not other proteins, other amino acids in the protein backbone. Nitrile, CN, aldehyde, CHO, we just happened to see that one in the example we just did. There's two things on the column as well. We have a precedent suffix. If this functional group happens to be precedent, this is how we name it. If it's not precedent, you have a prefix, usually a prefix, for naming it. And you'll be able to go back and look at this table when you are doing the worksheet. It's actually added to the worksheet, and it happens to be in this order. So fairly easy to see them. And unfortunately, the red sticks with us, so apologies. Aldehyde is a double bond O, C double bond O, in the middle of two other R groups. Alcohol, you've seen lots of, ethanol, methanol, propanol, isopropanol, and the like. If I replace the oxygen with a sulfur, sulfur is directly below oxygen, we end up with a thiol, or SH. And nitrogen by itself is an amine, and it can be bonded to up to 3 different R groups, or hydrogens and the like. And then we have ethers, ROR. Alkenes is now when we're starting to form double bonds with, we're now starting to form double bonds within the hydrocarbon chain itself. So a double bond, the ANE suffix goes to ENE as an end group there. And I'll just get out of your way so you can kind of see what that shows. And like I said, we're going to refer back to this when we end up doing these examples. After alkenes, that's a double bond with an alkene. An alkyne is a triple bond. And this suffix just goes from an AN to a YN in here. Halides are unique in the sense that even if it is precedent, it sits before the alkane name. And that's just a unique feature of halides. Nitro group and alkanes by themselves, if it is coming off as a side chain, we give it the term alkyl. And so in the example we have here, we have methyl off of the butane backbone. Like I said, we'll come back to this list of functional groups as needed to figure out both their precedence and how to name them. So what do we need to do? Well, between 1 and 2 done together, we need to identify, I'm just looking at 2 first actually, we need to identify the functional groups and side hydrocarbon chains which are given the term substituent. What's attached to the main hydrocarbon chain? That main parent chain is the longest chain of carbon atoms, that contain the highest precedent functional group. So we need to know what the functional groups are, we can figure out what the highest precedent one is, and then figure out what the longest hydrocarbon chain is that contains that highest precedent functional group. If the hydrocarbon chain, if the entity contains an alkene or an alkyne, we try to keep that alkene or alkyne in the parent chain, even if it breaks the longest longest chain rule. And once we have identified all of the substituents and the hydrocarbon chain, then we can put them in order. We want to number the carbon atoms of the parent chain such that the substituent with the highest precedence is on the lowest numbered carbon atom. And once we do that, then we identify the position of each substituent on the parent chain. The locant is just the location, the number of the carbon atom where they are bonded to. If we happen to have more than one of the same substituents, we're going to add the prefix di, tri, etc. But we also don't need to add the locant if the substituent can only exist at the end of a parent chain. So things like alkenes, not alkenes, that's what I'm not wanting to say, carboxylic acids and cyano groups can only exist at the end of a parent chain. So now that we have all of this information, we can write the chemical name. And that's what we're going to do. How do we write the chemical name? We have the main chain in the middle, and the non-precedent substituents are put before the main chain in alphabetical order, ignoring di, tri, etc. prefixes. We put them in alphabetical order before the main chain. Then after the main chain, we put the precedent substituent, locant if we need to, after the main chain. And I guess, again, halo is an exception. Halo always goes before the main chain as a prefix. So, in terms of punctuation, when we're punctuating the name, commas are used to separate numbers. Hyphens are used between a number and a word. And if we have things that are complex, we'll put that complex substituent in brackets, like methyl ethyl or whatever the case is. And that is the procedure for naming organic entities. It's a lot. We're going to go through examples. I'm actually going to back up to the original slide, and we're going to name some of the ones there, and then we're going to come back and name the things here. Not going to have time to do them all, but we're going to get done as many as possible, and then I will create a video, or I will upload all of the ones that the other ones that are at the back of this resource. So here we have these structures. I'm going to need to draw them out in order to do this procedure, and that's what we're going to do right now. So just to look at the first one, I'm just drawing it out quickly. Something like that. I'll erase what I don't need. CH3, CH2, CH2. And here, this was bonded to two CH3 groups. Then there was a CH2, a CHBr, and a CH3. So there we go. That is that first entity that we have present there. We need to identify the functional groups. Okay. And in terms of identifying the functional groups, we have the halo, bromine, and we have these two methyl groups coming off of there. So in order of precedence, if you look on the data sheet, or on that functional group list, the bromine is precedent over top of any alkyl group. So we need to number this such that the bromine is the lowest. And in doing that, of course, the other option would have been to number them in that order, but that puts bromine as 6. The first order puts it as bromine as 2, so we'll stick with that. Our parent is 7 carbon atoms, and so our parent is a heptane, excuse me. That is our parent. And off of that, we have, at the 2 position, bromo. And at the 4 position, and because there's 2, we're going to put 4,4-dimethyl. So di infers 2 methyl groups, and we're putting them where they're at. They both happen to be on carbon atom 4, so it's 4, 4. If one was somewhere else, it could be 4, 6, 4, 5, whatever. And now we have all the information we need to write the name. Bromo is precedent. Use a different color. But because it is an exception, it actually still goes before, and it is put in alphabetical order. Alphabetical order puts B before M. So the name of this compound is 2-bromo dimethyl heptane. 2-bromo-dimethyl-heptane. Oh, thank you for that. I'm bad. 2-bromo, I should have, 4,4-dimethyl-heptane. Should follow my own rules, right? 4,4-dimethylheptane. Thank you very much, Pollock and Mark, for pointing that out. My bad. Can I explain the 4,4 part? Sure. It's saying that there's 2 methyl groups, and those 2 methyl groups are both on the 4 and 4, the 4th carbon atom in. Does that answer your question? Good. If they were somewhere else, and I'm just going to do a bit of erasing here and erase that. Oh, put a carbon atom there and there. What I just did over here would be 4,6 dimethyl. I hope that illustrates that. Next one. We have that and CH2, CHOH. Oh, and then a CH3 group. So there's that, and then CH2, CH2, CH3. Done. That is the next entity we want to look at. In terms of functional groups, there's a carboxylic acid group there, there's an alcohol, and then there's a methyl group. Carboxylic acid is highest precedence if we were to go look it up. So we number the carbon atoms from there and find out we have hexane. And off of that hexane, we have carboxylic acid. We have off of the 3, this is off of the 1, but we don't need to put that in there. But off of the 3, we have an alcohol. And off of the 3, we also have a methyl. And so in terms of naming this, the alcohol functional group changes the ending, so we have dash, okay, I'll write it out as hexane. Normally it would just simply be hydroxy, right, my bad. When it is non-precedent, it's hydroxy. 3-alcohol becomes 3-hydroxy. And so we can now literally write the name of this. The non-precedent groups are written in alphabetical order, and we have H and M. So one would write this as 3-hydroxy, 3-methyl hexanoic acid. Hydroxy, 3-methyl hexanoic acid. Okay. Oh, the carboxylic acid, the way one writes this is oic acid. That is how it is presented to define it. So we've changed the suffix from hexane to hexanoic acid. And we don't need to put the 1 there because the 1 is by definition the lowest carbon atom, and the carboxylic acid can only exist at the end of a chain. So it can't exist midway through. So we don't need to put the 1 there. Good questions. So look at the next one. There. CH2, CH2, the bond CH with a methyl group. CH2, CH2, OH. There we go. There's that structure right there. The only non-alkyl functional group is the hydroxy, or the alcohol, excuse me. It's not hydroxy anymore. So that becomes precedent. And we also have the alkene and the methyl group coming off of there. So we can number the carbon atoms from here. 1, 2, 3, 4, 5, 6. So this is still, hexane is my parent group. I have off of the 1, I have an OL for the alcohol, because it is precedent. Off of the 3, I have a methyl. And off of the 4, I have an alkene coming off of there. And the reason why the alcohol, this up above, it is not precedent. And so it's given the name hydroxy, and here it is precedent. How do I know what order to put them in? The precedent one is going to, well, it's alphabetical for the non-precedent groups. The alkene, if we go back and look at the sheet, the nomenclature for alkenes would take hexane and convert it to hexene. So that is how the alkene is represented. But we also need to take into account the alcohol as well. So when we write this thing out in full, we have 3-methyl. Okay, then we have hex. And then off of the 4, we have an alkene. And then off of the 1, we have the alcohol. 3-methyl, hex, 4-ene, 1-ol. Does that answer your question, Taylor? So to look at Pollack's question, if I were to go in the opposite direction and want to convert this to a structure, I would look at, hey, I've got hex. So if I just draw 6 carbon atoms, 1, 2, 3, 4, 5, 7, whatever, carbon atoms, and I'm just going to randomly number them. It doesn't matter. I'm actually going to put them in the opposite order. 1, 2, 3, 4, 5, and 6. Okay? Because that's how you would number them. Off of the 4, I have an alkene. 1, 2, 3, 4. So there would be my double bond off of the 4. Off of the 1, I have an alcohol. And off of the 3, I have a methyl group. So that is how I would go in reverse. Does that make sense, Pollack? In high school, we were taught that the carbon atom attached to a functional group with the highest precedent took precedence. Is this still go? Yes, that's what I'm saying. That's why we number it as number 1. Oh, hold on. The carbon atom is not precedent. I could put the alcohol, just let me draw this out again. So, okay, there's that structure. If I were to put the alcohol group there, for example, because I can, it is still numbered with that situation as presented there, except now in terms of naming this thing, it is still 3-methyl hex 4-ene, but now 2-all. So the alcohol is now on the 2 group rather than the 1 group. Does that make sense, Mark? Good, excellent. I hope that that actually matches what you got in high school, because it's correct. So what we have here is 3 pages of examples. And like I said, I've only got about 12 minutes left in class. I don't have time to go through all of these examples. So I'm going to do a selection of them and then work through all of them and put them online. So you'll be able to see all of them there. And then you will give, it's meant to be representative. The procedure, once you get the procedure that I am trying to follow the same all the way through, once you have that, then it's just a matter of following that same procedure and looking at the functional group table and figuring out where things go. So here we have, I'm just going to randomly pick some of these. Well, not quite random, but you get the idea. And the first one I want to do, excuse me, will be the 1,1-dichloro. Two difluoro ethane. So I have ethane, which is my parent hydrocarbon chain. And off of the 1, I can arbitrarily assign 1 and 2 to these until I start putting things on. Off of the 1, I have 2 chloro groups. And off of the 2, I have 2 fluoro groups. And that's the structure. If you want, you can remember that there's hydrogens as well to give you the full 4 bonds around each carbon atom. I want to do that long one on the bottom right. As presented there. So I need to figure out where the longest hydrocarbon chain is. And a couple of different options. One of the options would be to go up and like that, and another option would be to go straight across that way. The lovely thing about the tablet is I can erase those and figure out which is correct. 1, 2, 3, 4, 5, 6, 7, 8. There's a possibility there. Or 7, 8, 9. So clearly the longest hydrocarbon chain goes up and around in that direction. So that 7 and 8 is not correct. So what do I have? 9 is nonane. And then off of that nonane, I have this functional group. Don't know why that didn't work. And these 2 functional groups. So off of the 6th position, I have ethyl. It's CH2CH3. And off of the 7th position, I've got dimethyl. And what did I do wrong? Did anyone catch it? The numbering should be lowest, exactly. I did the numbering to begin with, and that was just to figure out where it goes. but I want to do the numbering such that the functional groups are at the lowest positions. So now this is 4-ethyl and 3,3-dimethyl. Good. That was intentional, by the way. I did mean to do that. So now we sit there and name this thing. It is done in alphabetical order. Done in alphabetical order, ignoring the di. So we have ethyl and methyl. So one would have 4-ethyl, 3,3-dimethyl, nonane. Go ahead, Efren.
For our 4-ethyl, is that referring to what's on the right of it?
Yes, that 4-ethyl refers to what is circled right there.
Okay, gotcha.
Good. I'm going to flip over to page 17 and to do another long hydrocarbon chain one. I have that as my example. And so looking at the functional groups that I have present, I have an alkene, I have an alcohol, and I got this thing up at the top. We'll get to what that thing is in a little bit. But in terms of longest hydrocarbon chain, well, the precedent atom will be the alcohol because you look at the functional groups, it's higher than that of any alkenes and the like. So 1, 2, 3, 4, 5, 6, 7, 8. My parent group is octane. And off of the 1, I have the alcohol, and it's because it's precedent, it's OL. Off of the 3, I have that group. That group is 4 carbon atoms in a ring. So that is simply cyclobutyl. And it's butyl, not butane, because it is a side chain. It is off the main chain, parent chain. And then I have off the 5 position an alkene. So in terms of naming this compound, I have the non-precedent groups, which is the cyclobutyl. So I have 3-cyclobutyl. And oct 5-ene 1-ol. 3-cyclobutyl, oct 5-ene 1-ol. Go ahead, Efren.
Sorry, another question. For the, so you put your oct before the 5-ene. Can you just explain the ordering again and like why those have to go in that order?
Sure, because I have octane is my parent group, and in order to form the alcohol would be octanol, that's ANOL. The alkene would be octene. And I have to now combine these two things together to give me, I have to combine these two things together. So because of where the EN fits in and where the OL fits in, you have oct-ENOL. Does that make sense?
So is that what that last bit is in your?
Yeah, that's what this is over here. And the only other thing that I need to do is I need to tell people where the alkene is and where the alcohol is. That's why there's a -5 and a -1 in there as well. Octenol.
Yeah, I think I get that. The numbers are still confusing me, like how, because I know like when you were building it like above, like when you were getting all your pieces, I got that. But then in the naming part, just the how you ordered it was confusing. But
Well,
I
the
think I
non-precedent thing, the cyclobutyl, is going to sit out front. And while the alkene is not precedent, the way the alkene applies is it comes in um, as octane to octene. So we're going to keep it where it's the normal location is. Let me do one or two more examples, and then we can get back to this if you're still confused. Okay, Efren?
Yeah, sounds good. Thanks.
Okay. Also on page 17, I want to just present this structure, which can also very commonly be represented as this. This is benzene. Okay. Benzene. And it has a delocalized double bonds in the ring, so that's where the circle comes in to represent the delocalized double bonding. Not getting into that, that's organic. But the structure that I want to look at is the one that has the NO2 group there and the chloro group there. And so if, excuse me, we look on the sheet, we find that the chloro, wrong color, is precedent, and we number the ring to make the other functional groups lowest number carbon atom. So my parent is benzene, and then I have 1 chloro and 2 nitro. That is the name of the NO2 group. So what do I do with it? Well, chloro also goes before the name, and now we just simply put these things in alphabetical order. Alphabetical order puts C before N, so this would be, in terms of a name, chloro, 2-nitro, benzene. And we don't have to put the 1 in front of the chloro because it is at the lowest carbon atom. We can number it starting wherever, and so we put the 1 where the highest precedent substituent is. Chloro, 2-nitro, benzene. And I have a little bit of time, just going to do one more. This comes off of page 18. I have this compound here. In terms of the functional groups, that is, oh, well, sorry. That happens to be an ester. And we have the iodine there. We actually have 2 hydrocarbon chains. 1, 2, 3, 4, 5. The ester group takes precedence in terms of nomenclature, and of course over here it's 2. Yeah, not a problem. If you look at how the name is put, the way that this is established is we have, like I said, these 2 groups. The 5 becomes pentane, is pent, is the parent group. And over here, it is ethane. This becomes ethyl. I could probably write that better. And the pentane, which contains the ester group would be written as, or sorry, that with a C2H5 group off of it is, excuse me, just to make sure I get the notation right. OATE, pentanoate. Pentan, T-A-N-O-A-T-E. Let me rewrite that just to make it clearer. Pentanoate. Off of that pentane, I have on the 3 position iodo. That is the iodine group. So in terms of naming this, I have ethyl, oops, wrong color. Three iodo pentanoate. Ethyl 3-iodo pentanoate. All right. Where was I going to go with that? We are done for today, and I will post the remainder of these. I'll probably actually just do a video with going through them all in order and naming these compounds and posting that up to YouTube so that everyone can go on there and watch them. Your worksheet has been uploaded to the organic nomenclature folder on Blackboard, and it is due, as it would be a normal lab, next Monday, submitted to your TA if you're in Chem 121, or submitted to me if you're not. I'll see what I can do about that, Benjamin. Sure. No, because it's actually a separate group. There is no dash there. It is actually, Alex's question is very apt. Should there be a dash between, in this location right here? And the answer is no, because it's a separate word. It's an ethyl group attached to the pentanoate. Good question. All right, everyone have a great, great day, and we will talk to everybody on Wednesday. We are going to be going back to the thermodynamics. So yeah, thermodynamics starts up again on Wednesday. See everybody then. Bye now.